talking.
Hi everyone, I'm Alvaro. I'm a hardware / firmware engineer. I talked to different BlueStamp programs like since 2012, I guess. Dave always gets me wherever I happen to be living at the time. But I don't really have any specific talk prepared, but in the past I've given a few different ones to different topics, so I'm just gonna kind of get a race of hands to see what more folks are interested in. So I'm gonna give you like 3 options and then I'll just ask. One of them is about how I became an engineer. So it's like a story from when I was a kid, what it took to kind of get to, I worked at Apple, Alphabet, the Google companies, Texas Instruments and stuff. I have another one of some of my hobby projects. One of them was entering a contest, which was autonomous robot for shooting these targets with laser beams. And then I have some of, like, I built a weather station and some cheese making equipment and stuff like that. So I'm gonna ask for a raise of hands. Who wants to hear about becoming an engineer and that kind of stuff? All right.
What are the other options?
So laser shooting robots.
Oh, those are the
Yeah, those 3, yes. Laser shooting robots. You got 1, 2, 3, 4, 5, 6. All right, and then the last one was some of the other cheese making and weather stations and stuff. 1, 2, 3, 4, 5. Okay, so I'll do the laser shooting robots real quick, and then I can show you some quick things about the other stuff. Now let me just find my slides.
I'm going to bring up the hardware meetups one more time, because the last one I was at, he had his weather station and was demoing his weather station. So if you would like to see projects like that or meet more people and like talk about projects that you can do at home and what other people are like tinkering with, those are a great place to go and show off some hardware. They're a lot of fun.
So this is a talk I gave at the Hackaday Super Conference. I don't know if anyone knows about hackaday.com. It's a project website where they put up different hardware projects every day. Hackaday. It used to be every day, now there's lots every day. But so laser shooting robots, like, why did I get into this? Back when I was 18 years old, I had just graduated high school and I found out about this conference called DEFCON, which happens every summer in Vegas. It's like a computer security hacking conference, I guess. And I was just really interested in that. And I found out there was a autonomous robot contest. And it had to do with a BB gun robot, and then there was these white targets you had to shoot at, and they had to do it all on its own. And I thought that was super cool. I had no idea about any of this stuff, but I wanted to do it. So my dad's friend was going to go, so then I felt comfortable going, and he's like, oh, we should build this project. And then he totally bailed on me, and so I had to do it myself. So I ended up using a little webcam mount and like an off-the-shelf little BB gun. And I took apart my dad's webcam. I later told him I took apart his webcam. And then I went to Vegas and I participated, and I didn't get last place. That's what I'll say. It was a lot of fun. So,
Can I ask what year that was? Or about
2006.
Okay.
Yeah, 2006. So, oh yeah. And this is a disclaimer. I'm a electrical / firmware engineer. A lot of the stuff I'm going to talk about is mechanical, which is just stuff I learned along the way. So I'm by no means an expert, but this is what I do with my side projects. I learn about areas I don't know enough about. So it started with these BB guns. Fast forward, I don't know, to 2013, they brought the contest back, but with lasers instead of BBs, because casinos don't like it anymore when you're shooting things inside of them. So it all started with me with some balsa wood cutting by hand, and then kind of building up from the project I did earlier, just like little servos. I saw a project with their little servos. I figured, oh, I'll put a laser thing on here and a webcam, and then I found out, like, yeah, servos are great, but when you're aiming pretty far away, if you have a little bit of error, it gets amplified, right? So then I started my deeply technical drawings. I started thinking of different ideas. Instead of the servos carrying it, I'm like, oh, I'm going to have some gears. I'm going to have a pulley maybe. And I found out about laser cutters. Do you all have access to one? Or I see 3D printers, right?
Yeah, well, if we needed something laser cut, we could get it done. But it's not
cool.
a general.
Yeah, no, I know this is kind of later in the project, but if you've never played with laser cutter, they're super cool. I don't have one. I went to a place that did. So I started experimenting with all these different like pulleys. I never used pulleys before. I mean, I've used them, but I never designed anything with them. Just playing around. And then, yeah, I found out these are more complicated than I thought. Turns out it has to be tight, right? So when you design your thing, and if you can't get the belt exactly the right size, so if it doesn't have tension, it's not going to work. So I would just cut them and super glue them together. Not the greatest idea, but it sort of worked. So I started building up on my little project. I don't know if you can tell which one of these is the handmade one versus the laser cut one. I started playing around with it some more. Yeah, so I had a lot of issues with the little motors. I started making gears. There's software you can just use and tell it, make me gear, and then you just laser cut it. Super cool. Normally they're expensive, but if you just 3D or laser cut them, you can also 3D print them and whatnot. These are stepper motors. I think I'm going to talk about that real quick. Anyway, up to this point, I've been just winging it, right? I haven't done too much, like, forethought. But then once I came to these things, I realized I had to do a little bit of math. Because if these aren't just the right alignment, they get jammed, or there's like a lot of play. So, yeah, and I ended up with this little robot there. But these are stepper motors. So originally I started with servo motors, and the servo motor, you tell it, I want you in position 0 to 100, for example, and it'll just move to that. But they're not super strong. These stepper motors, I don't know, has anyone played with stepper motors here? So stepper motors, you basically tell them to step in one direction or the other. So you tell them, okay, I need you to step 5 times in one direction, and then it'll go 5 times there. And they're really useful for, like, if you see your 3D printers, that kind of stuff, they're used for that. Then I started, I wanted to learn how to make 3D models. Again, I've never done this before, so it's like, oh, well, let's try to play with this. So I started designing a new kind of robot thing. And here I have some toy, like, tires. And this is one of those, like, spinning tables with bearings. I don't know what they're called. Lazy Susan, yes. I knew it had a funny name. And then I have a motor that spins the wheel, and then it turns around. And so I started laser cutting those things. I made some mounts to align the camera with the laser beam. I found out commercial webcams don't usually have tripod mounts. So I had to glue stuff around. So this is what it ended up looking like. And it's totally different from what I started with, but I was just kind of playing with it. I found out that this doesn't really work. When this wheel would spin, this whole thing would just get pushed off. So it worked great in my head when I got here, and it didn't quite work. I also found out to use limit switches. If you don't know what a limit switch is, this motor will start spinning, and this will go around, but there's all these cables behind there. So if your software doesn't tell it to stop, it's just going to keep spinning and rip itself apart. So limit switches is just these little pieces of wood. You're going to hit these switches and basically disconnect the motor, like a safety mechanism. And I didn't use those at first, so like, oh yeah, my software is going to work, and then it crashes, and then it just goes and rips itself apart. So then I decided to make it a little more complex, and I started using epoxy and super glue to put the bases of these together. So I could no longer fit this on the laser cutter I was using, so I had to print separate pieces and connect them all together. So now you can see there's more kind of things to hold it in place. I built 2 of them because one of them always breaks. That's a great lesson. If you ever go to a competition, bring 2 of everything at least, not more. I ended up taking one of these webcams apart and just putting it in there so it's closer to the laser as possible. Because the further away you are, it's not really aiming at the center of the screen, if you will, and you have to do some more calibrations. You can see here there's some rubber bands going around this piece of wood. I found out that if it's not just right, it's not going to work, so I had to kind of make it a little bigger. And I did this already at the competition, and the casino. It's not working, you got to make it work. Okay, so we won the contest, and we got a quadcopter out of there. But anyway, the next year, they're like, oh, we're doing the same thing. It's going to be a little more complicated, but essentially the same thing. I didn't want to use the same robot because that's boring, so I decided to make a totally different system. So I found out about these things called galvanometers, which is these little, not quite like motors, and they have these mirrors on them. And the galvanometer can very precisely position itself, but only, like, it doesn't spin around in circles, but it can just go like this. So if you shine the laser beam from one to the other and you move one or the other, you can aim the laser beam anywhere really, really, really fast. And it's fun. So I started playing with just clamps and webcams and stuff, and I found out that precision mounting optics is hard. If you've ever been to a lab or you've seen it in a movie or pictures, a university lab or a research lab, they'll have these huge, very heavy tables with screw holes all over them. And then they mount all these optics very precisely. You have your lenses and your laser, all that stuff. I was working in my bedroom, so I had to find some way of putting all this together. Again, I did have to do a little bit of math, and I mounted these guys, and then ended up with this gizmo. Behind these two is the drivers for the galvanometers, and then there's just a laser beam, and then there's the webcam. And these things are called open beam, and it's extruded aluminum. There's fancier versions of it that are bigger that are used in industry a lot for just putting together stuff. It's really easy. You just slide like a nut in here, and then the screw goes up there, and you can make all sorts of cool stuff with it. You can see here at the back. These I just bought off of eBay. It's like a little laser show. They sell it for doing crazy lights for music. So I just reused it. I tried all sorts of different contraptions. One was shining from above, whatnot, and then I had to test it. So at home, on the actual contest, is a little train, and like a model train track, just going around with these ping pong balls on top, if you will, and they shine blue, and then when you shoot them, they detect the laser got hit. So I was trying to simulate that in my living room. You can see here that there's one of the ping pong balls, and you can actually see the laser beam. The second year, the laser beams were green, much more powerful. Actually, I had to wear safety glasses, but they looked really cool. Then I just had some slides about how I drove. Oh yeah, the laser actually had data encoded in it. You're not just shooting a laser, you're sending data over the laser saying, I am team 1, 2, or 3. I'm actually shooting, and you could get more points if you said, oh, I'm shooting a target 3 out of 5. Which we didn't do because it was really hard. I made some circuit boards to simplify the driving of these guys because they take the differential voltage. So you don't just send a voltage from like 0 to 5 to tell it which position. You have to send a positive and a negative, like an inverted version of itself. So I made a little circuit to do that. It's really nice to pack when you use this extruded aluminum because I had to fly to Vegas. You can see all the pieces we had, and again, this is two different sets. And this was the actual contest. I didn't take many pictures, unfortunately, but you can see this train track, and there's a little train there. And yeah, I want to say the thing didn't quite work when we got there. Like it shot all the things, but the data transmission wasn't quite working. We think it's because of all the mirrors; it was getting degraded or something. But yeah, so that's just the quick laser shooting robust thing. And if we have any extra time, I can show some of the other stuff. But if anyone has any questions about this, Yes.
Do you have any problems transporting like circuit boards and wires over the plane?
Not as much as you'd think. Yeah, I know. For work, I've also traveled with lots of electronics. This is even sketchier because you're like bare wires and whatnot. I haven't gotten too much trouble. Like the first time when I had the BB gun, and I checked the bag, they actually opened it and looked at it, but I just told them, like, hey, can I be there while you open it up and check it, just so it's not, and yeah, it's honestly, they looked at it's fine. Nowadays, they really don't want, if you have anything with batteries, you can carry it on because they don't want the batteries down below, so it's a great excuse, like, oh, it's got a lithium battery, I gotta take it with me. Yeah.
How did you send the data through like the laser?
So we were just turning it on and off really, really fast. So these laser module actually has 3 wires coming in. You have power, you have ground, and then you have an enable signal. And you just pulse it on and off in a particular way to transmit the data. Yeah.
So I don't know if this was covered before, but like I don't really know what the difference between like a normal, LED or a light is versus like a laser. So like what exactly is a laser?
Oh man. So there's an acronym for it, but it's basically one particular wavelength of light, and it's really focused, and it's, yeah, with the right lens, it'll just go straight. It's really, really focused light, right? And much higher power. Because like your LEDs will just shine light everywhere, and those also, you can make them particular wavelengths, but I'll have to look online, because there's also the chemical lasers, or there's ruby rod lasers where they actually have a piece of ruby and they're shining really bright light, and then it excites the electrons, or something like that. I don't know. Yeah, I just bought them online. But. Any other questions?
Are you still doing more of these robotics competitions?
I haven't done these. We did that a few years, and then I was supposed to organize the one after because the organizer had a kid. And then I was overall with work and then didn't end up doing it. Yeah. Yeah.
What does firmware engineering do?
Okay, firmware engineering. So has anyone here been working with Arduinos or anything like that? So Arduino, yeah, it's a microcontroller, right? So you have a little chip that's got a tiny computer in it. And the software you put into those is, we usually call it firmware. So whenever you have a processor that's used for a single purpose, if you will, not like this processor, which is general purpose. You use it to run an operating system with lots of different software. Microcontrollers are usually doing a single thing or a limited set of things, and we call that code firmware. So it's just still writing code, but it's running on hardware, and you're usually interacting more with the physical world. Yeah. Any other questions about this stuff? Okay. So I can share really quick some cheese making stuff.
I love that like so much of this stuff just like relates to like childhood things. Like the aluminum sort of reminded me of like those Kinect toys.
Oh yeah.
And then like the lasers. All I could think about. Do you remember that game where you'd shine lasers and you'd have mirrors and you have to place the mirrors to try and like shine your opponent's target with the lasers?
Oh yeah, it's like chess with lasers.
Yeah.
I've heard of that.
Okay, well I had that as a kid, and that's all that reminded me of. If you've not played it, it's really fun.
And we didn't have that in Mexico, I guess. I don't know.
I remember shining lasers in my eyes on accident, so probably not the safest.
No, well, it depends. Like, there's different classes, and some it's.
I don't know. It was the 90s.
Oh, this is another talk I gave. Let's see.
I don't remember.
So I'm just going to do the very beginning. I gave it an open source hardware conference last year, and it's just like learning electronics again. I'm doing this on my hobby time, if you will, and I learned a lot by making mistakes. So I share my mistakes so other people don't make them. So I really like cheese, so you can tell. I even have a cheese board that looks like cheese. I also like electronics, so I figured I'd combine the two, right? I'm going to give you a really quick lesson on how to make brie. Has anyone not had brie in the past? Yes. So it's just like soft cheese. So really fast, I'm going to tell you, you have ingredients, you have milk, you have heavy cream, you have rennet, which is a coagulant, you have calcium chloride, and some bacteria and mold, and then some other stuff. So you warm up your milk really fast, you add the bacteria and the rennet, and then it curds, so it basically solidifies. So you can actually cut into it. After you cut into it, you get the curds, you put it in the mold. Yeah, no, this is...
Don't watch there, it's okay.
And then you let it, you let the whey, it's like this liquid fall out, and then you have this kind of gelatinous thing. And you put it back, you add some salt, not that much salt, but some salt. Yeah, I found that out the first time I made them. And then you let them age, right? So this is what a professional aging thing is. This is somewhere around here, like a couple hours drive. And this is Gouda. But this is what mine looks like.
We want to go eat the cheese.
Yeah, it's good.
We want the cheese.
So I use Tupperware containers or just my fridge, and then I have this whole system I use. So this, I don't know if this is going to work. Oh yeah, so I did a time lapse of, and this is mold growing on it. So the rind of brie is actually this mold, and that's what ages the inside and gives it its flavor. Then you wrap them, and then you age them some more, and then you wait, and then you get brie. So I might have skipped a few things, but there's like specific temperatures and whatnot. But anyway, yeah, I did a lot of things for the fridge, but since we don't have a lot of time.
Did you highlight the do not puncture right as you punctured it?
Oh yeah, well I can cover that part. So you need to control the temperature and humidity. And you can use your big fridge, but then you can only use it for that. So I bought a small fridge off of Craigslist, and I wanted to get my sensors in there. So I drilled a hole, and that was fine. But then I wanted to add more stuff through there. So I drilled another hole, and that was not fine, because there's a copper pipe here with the refrigerant. So I released all the gas into, yeah, so I did that. I don't do that. So I had to buy a new fridge. So now I just put the cables through the door. I'm just gonna fast forward to the fun ones. So I made different controller boards to control the fridge, monitor the temperature and the humidity. Yeah.
How do you make those boards?
I use open source software called KiCad, and it's just on your computer. You do a schematic, so you just connect all the components together, and then you go to the PCB layout, and then you can make these really cheap online in a website called Oshpark, and they charge you like $5 per square inch for three of them. So this will cost me like, I don't know, $20 or something for a few. Some soldering. Oh yeah. So then I ended up making cheese-shaped circuit boards. And these ones have a temperature and humidity sensor. So I put one of these in each Tupperware container to monitor the temperature and humidity of my aging of the cheese. And then this one measures all the data and then turns the fridge on and off to do that. So then, of course, I had to make it yellow. So this is kind of what it looks like. Yeah, this. Yeah, there's a humidity sensor. And that's kind of what it looks like in action. You will have the controller, a little relay that lets me turn power on and off the fridge, and then the three controllers there. Yeah, and then I also hooked it into this server to get the data so I can actually look at my cheese plots and whatnot. Yeah. Yeah, anyway, that's a quick, super fast run through of my cheese making project.
Could you use all of that sensor equipment to make other types of cheese by just changing the required humidity?
Yeah, absolutely. The brie is actually one of the cooler ones, but for Gouda, for cheddar, all those, it's at the beginning you do a few different things before you put it in the fridge. So some you'll actually use a press, so you kind of squeeze the cheese curds, squeeze all the humidity out, all the moisture out, I guess. And then some you wrap, some you don't, and then you keep them at different temperatures for a different amount of time. But yeah, you could just change the settings.
What happens if you skip a step, like wrap it if you're not supposed to, or don't wrap it if you're?
So the brie, if you don't wrap it, it dries out. Okay. And I've done that. It just...
Is it just not as good?
How long did you age
About 4 to 6 weeks. So brie is fairly short. Like a Parmesan might be a few years. If you do mozzarella, you can do it in a few hours. So it's really depends.
Was it like above average? Or was
So
it like
I took it to work and people didn't believe that I made it. So the second and third batches, like people thought I bought it. So I thought that was good. And then I moved to the apartment and then I haven't been able to make good ones since. So it goes kind of go back and forth. Yeah.
So how did people do this like hundreds of years ago then? Because like it seems like there's like specific temperatures and like humidities that you.
So I don't know if you've heard of cheese caves, like where I showed originally. That's literally what they would do sometimes, or in a basement. And in certain parts of the world, like in France and stuff, there's certain, like a basement, an old stone, like building, it stays at that temperature usually. Like, I don't know, Fahrenheit, I'm just gonna make up a number, 50 Fahrenheit, whatever that means. I imagine that and a certain humidity. And they would just age them there. And then later they go and measure it. I'm like, oh, okay, this is what we should use but that's why like Camembert cheese is similar to brie, but it actually, to be called that, it was made in the region of Camembert, France. So there's, it's just how they did it in the locations, that's where it was. Like blue cheese, I don't know if you've seen blue cheese, it's really stinky and it's got blue mold in it. They actually inject the mold from old bread. That's how they discovered it. They had like old bread was growing mold, and then the cheese that was next to it ended up really tasting really good. And they're like, "Whoa, how do we do this again?"
This happens in so many labs. That's how penicillin was invented. Mold grows. Messy scientists.
Any other questions?
What else, like, how much of your time do you spend, like, tinkering and hobbying versus, like,
A lot.
actually working?
It's pretty close. Depends on the work. Like if I'm having a lot of fun at work and I'm doing lots of challenging things, then I won't be doing it as much at home. So when I'm working, like I worked at Apple doing R&D for several years, and I was mostly doing firmware, so I would do a lot of hardware projects at home. Then I worked at another job with a company making small satellites, and I hated it. And I did a lot more stuff at home because I was just not being stimulated at work, if you will. So it really depends. Yeah.
Have you ever thought about like opening up your own cheese shop?
Some people have suggested it. I don't know if I would. I think I'd be more likely to make like a kit and it's like, hey, do it for your own, or I would love to go into a professional cheesemaker and be like, hey, what hardware would you find useful and make something? Yeah. I don't know if I would like the day-to-day deal with people and yeah. Yeah.
How do you usually consume your cheese?
It depends, but I'm a purist. I'll either have it by itself or with some bread or some particular types of crackers and stuff. But you can also do melted cheese. Is one of my favorite ways. I'm from Mexico, so quesadillas are since I was born. Basically, I've been eating those, right? But like fondue, just melted. All these different kinds of melted cheeses with bread are really good. You can also do like brie with apples and walnuts and honey. That's pretty good if you mix it certain ways. Yeah, I don't know if that was what you were asking, but that's what you got.
What's your favorite cheese?
That's an impossible question, but
The cheese that I'm eating right now.
yeah, I've had bad cheeses, but most of them are good. But one of my favorites I discovered a few years ago, and it's called La Tour. It's a 3-milk cheese, so it's got goat's milk, sheep's milk, and cow's milk. And it's soft, and it is fairly strong, but it's really, really good. It's like a spreadable cheese, though.
Just what are some other things that you've tinkered with recently or built recently? Like even if you don't have slides about them, like what are the types of things you're working on?
So you mentioned earlier I built a weather station. That was just for my dad's birthday because he's a huge nerd too, and he likes measuring everything. So I could have bought him like a off-the-shelf little weather station, but that's no fun. So I built one, and so I've been learning about waterproofing enclosures because it's going to withstand the rain, and radios because you can't just connect it. It's on the rooftop of his house. So I've been learning about that. The cheese making. I've been playing with Bluetooth stuff like for lights. I have, it's not working right now, but at some point I had under my bed a bunch of LED colored strips and these motion sensors. So when I would walk either off my bed or up to it, it would light up kind of dim light, so I wouldn't have to turn the